Okay, welcome back. We're done with magnets and magnetic materials. We're now going to move on to magnetic induction. Alright, so the learning roadmap for today, for this video, is why are magnetic materials attracted to magnets? That's the real question we're asking, right? Obviously, what we're going to cover is magnetic induction. But the question that I want to pose for you to think about now is, why are magnetic materials attracted to magnets, right? Why? What happens, right? And to answer this question, we'll answer these two questions. Of course, what is induced magnetism and what are magnetic domains? Okay, what is induced magnetism and what are magnetic domains? So let's jump into the first one. What is induced magnetism? It's supposed to be a group activity, but we can't be doing that because, you're at home. So I'm going to go to the handout and you're going to pretend, I'm going to go through the handout so you can know what you're supposed to be doing, and then I'm going to, just tell you what happened. So, we're going to investigate magnetic induction. That's what I'm supposed to do. So I'm supposed to tell you to clamp a bar magnet on a retort stand as shown above, place a paperclip vertically at the bottom of the magnet, and place another paperclip at the bottom of the previous paperclip. What do you observe? Alright, so what do you think you observe? I don't know if you've played with magnets before in primary school. I think the coin is too heavy to demonstrate this. Yeah, it's too heavy. So anyway, what do you think will happen? Next, I tell you to try adding more paper clips, each below the previous. What do you think will happen? And I ask you to explain how this happened. And just come up with some reason. What do you think is going on here, right? In your own words. I just wanted to see what you can come up with creatively. And then I'm going to ask you to remove the top paper clip from the magnet and ask you, what do you observe? So after the whole, what's going to happen, of course, is that when you place the first paper clip to the magnet, it is going to this might work though. So so I have this better magnet here, so maybe this might work. So I've attached one and then I attach another. Oh, look at that, right? So I'm going to attach one, attach another, and then I'm going to attach another. Whoa, what just happened here, right? So again, sorry, you have to look at a very tiny screen. Oh, it's dripping water from just now. So anyway, so what's happening here, right? So what you observe is that it just keeps connecting. It just keeps being attracted to the coin previously, or the paper clip previously, right? And then I ask you to next remove the top paper clip from the magnet. So I'm going to remove the top paper clip from the magnet. What do you think is going to happen? Just look at that. Everything falls apart, right? Why? Why do you think everything falls apart? Why were they attracted to the magnet previously, and why does everything fall apart after that, right? And then the next one, I ask you to try holding a single eraser vertically. Single, I can't do this, I don't have enough hands. Vertically, one eraser, and then try putting the coin below. What do you think will happen if I let go? If I let go, the coin falls right down, right? But one single eraser is not the length of 3 coins is much longer than one eraser. Can you see? So this third coin, previously when I put one eraser, right, can you see this third coin is much lower than one eraser? So even though I had one eraser, only one eraser away, the coin didn't even stick to the magnet. So somehow the magnet's effect is somehow passing on all the way down to the third coin, more than if I just put an eraser here, right? And somehow the magnetic effect is completely gone when I remove the magnet. Question is, why? Why does this happen? I want you to use your creativity to tell me why, but it's alright. We'll just cut to the chase before this video becomes too long. Okay, so let's go back to the slides first. Yeah, so this is supposed to happen, your magnet's supposed to connect, and then so ask you why. Hold that thought. Why? Hold that thought. You're supposed to next do the next part of the group activity. Next part of the group activity is this. you're supposed to hold another clamp below. A bar magnet on top, and then a string, and then a paper clip, and then of course you know that the paper clip will be attracted to the magnet, so it's gonna have this, like, it's gonna look like it's flying, but really it's because it's attracted to the magnet, which is pretty cool in and of itself. But that's not all. That's not the purpose of the experiment. What I'm gonna tell you to do now is to bring a north pole close to the paper clip, bottom of the paper clip, and you're gonna see what happens. So what do you think will happen if I bring the north pole close to the bottom? What do you think will happen to the paper clip? Will it be attracted? Probably, right? Probably, right? Let's I mean, I wish you could do this yourself and go wow, but you can't. So whoa, no.
Guys, today I'm going to make a brief video on induced magnetism. Now here, I've got a bar magnet, and this is the north pole of the bar magnet. And suspended on this little piece of string here, I've got a paper clip. Now the paper clip, this is the north pole here of the bar magnet. A south pole is being induced in this end here, and therefore this is a north pole here. And I can show you that it must be a north pole because if I take another bar magnet, and I go close enough to it, you actually see the paper clip starts to repel. So you actually got two like poles here that actually causes the paper clip to be repelled away from the magnet. If I bring the other pole of the magnet, it'll actually be attracted towards it.
Okay, so do you see that? Yeah, so when you brought the north pole in the lab, when you brought it, you would have seen that the paper clip will start to move away from the north pole. Repulsion takes place, and from the previous video we learned that once we see repulsion, then it must be a magnet. Both must be a magnet. But how? It's just a paper clip. So somehow, when you put this paper clip near to this magnet, such that when it's like the effects of the magnet can be felt by, like, for this example, attraction, somehow this paper clip became a magnet itself as well, right? And you know that the bottom here is the north pole, because here when you put a north pole here, it repels away. So if this is a north pole, means the opposite end must be a south pole, and that makes sense because a south pole is attracted to the north pole. So what do we get here? What we're saying is when you bring this paper clip near to the magnet, somehow a magnetic pole is induced. The word here we're going to use is induced in this paper clip, and this paper clip itself becomes a magnet. Amazing, huh? But when you remove the magnet away, what will happen? Just like all the coins, you see how they all fell down? It no longer stays a magnet. So it's only induced, it only has magnetic induction. It's only an induced magnet because it was brought near a magnet. Okay, and that's the key idea of magnetic induction, which is we're just going to slowly explore more and more and figure out why things work the way they do, right? But this is like our investigating procedure, and we're investigating and we realize that, hey, wow, when you put a magnet near a magnetic material, actually why is it attracted? It's attracted because that thing becomes a magnet, a mini magnet, and the thing's called a magnet, so it gets attracted, right? So what is magnetic induction? The process whereby a magnetic material becomes a magnet when it is near or in contact with a magnet. Okay, I think there would have been a boom sound, but this PowerPoint slide doesn't have a boom sound because I'm recording on my tablet, so take this down, yeah? Okay, so yeah, handout 1, question 2 to 3. Okay, let's go. Handout 1, question 2 to 3. So indicate the poles induced in the paper clips in the experiment below. Yep, pause the video, go for it. In fact, go for both question 2 and 3, and then hit play when you're done. Alright, so here we see it's a south pole, so we know that this becomes an induced magnet when you bring it near a magnet. So this becomes this is south, so this must be north. If this is north, then this must be south, and this is south, this must be north, south, north, south. Do you all manage to get that? Is that too small? Big enough? Alright. Okay, fairly straightforward. Next one. Next one's a bit tricky, right? The north pole of a magnet is brought close to the center of a needle, where the poles induced in the needle X, Y, what are the poles, what are the poles induced X, Y, and Z? So this is South Pole, this is North Pole. So here must be a North Pole, and if here's a North Pole, the two ends must be South and South. Okay? Because they are opposite ends of the north that is induced in the magnet here. I mean in the needle here. Okay? Alrighty. Okay. Hey, my animations. Oh yeah. Okay, you just cover the screen yourself. You pretend you cannot see, okay? So, handout 1, question 4. So it's actually, let me just go back to this. Handout 1, question 4. In an experiment, a piece of wood is held between north pole of a bar magnet and 2 paper clips. So you see this? North pole, wood, and 2 paper clips. Then we see that even though wood is a non-magnetic material, the 2 paper clips are attracted when the wood is held between the magnet. So the paper clips are still attracted to the magnet and they can hang in mid-air. I mean, being suspended there. Suggest a reason for this. Okay, why? The paper clips are magnetized by induced magnetism. This process does not require physical contact between the magnet and the magnetic material. Right? So if you look here, earlier I said that near becomes a magnet when it is near or in contact. Okay? It doesn't have to be in contact. Being near is enough. So paper clips are in fact magnetized by induced magnetism, and this process does not require physical contact, so the magnetic material only needs to be near the magnet, so that is why it's attracted. Okay, so it actually becomes a magnet and then it's attracted. Alright, okay, cool. Part B. It is observed that the bottom tips of the paper clip point away from each other. Why is this so? Do you think I can do this with my magnet? Just to show you that I'm not making this up. No, I don't think I can. Okay, I actually managed to do it. So, but without a piece of wood there. So if I just were to put 2 coins here, close to each other, what do you see? In the magnet, if I try to push it, it will repel away. Can you see that? So I let go and it repels away. So why does it repel away? Why does it repel away? Alright, so what do we know about induced magnets? If this is a north pole, then this must be a south pole and a south pole, and then what about the opposite ends? This will be a north pole and this will be a north pole. And what do we know about like poles? We know that like poles will repel. Right? And that's it. That's simply it. Right? So this further demonstrates that these actually really become little magnets, right? So the reason why it's attracted and all these things happen is because when you bring a magnetic material near a magnet, it becomes a magnet, right? So the explanation for part B is here. Yep, the top of both paper clips have an induced south pole because of the north pole of the magnet. And so the bottom of the paper clips have an induced north pole, like poles repel, and so they will be, the bottom of the paper clips will point away from each other. Alright, cool. Yeah, I hope this was fascinating to you. I think it's super. I think magnets are one of those super fascinating things, because they don't act the way you think things normally do, right? Oops. Okay, so with that, we've covered why are magnetic materials attracted to each other, attracted to magnets. Firstly, what's induced magnetism? Why? Because they become induced magnets, right? They become induced magnets. But the question is, how does that work, right? We still want to press a bit further. How does that work? Why do they become magnets? And we'll answer that in the next video when we talk about what are magnetic domains. See you in the next video.